Yes.
Good afternoon, all.
Abam,
On
start.
behalf,
We are live now.
Good afternoon, all. On behalf of Department of Information Technology, Srinagar Institute of Technology and Science, I would like to welcome all the participants and today's guest of honor, Mr. Adnan Khan. Let me introduce our today's guest. Adnan Khan sir is currently working as a senior software engineer in Wipro Arabia Limited. So, to brief his profile, Adnan Khan is an experienced technology professional with hands-on experience on Hadoop, big data technology, and cloud computing. He served Capita, Impetus, and Teradata in big data projects as Hadoop administrator and senior technical consultant. He has trained and mentored more than 250 people in India and US through online and classroom training, and worked with global clients and teams like US, UK, Dubai, and India. Uh, he is Hortonworks Certified Hadoop Administrator, AWS Business Professional, and AWS Technical Professional. With this, uh, I would like to request our today's guest speaker, Mr. Adnan Khan, to go ahead with his session. Over to you, sir.
Thank you so much. Hello, everyone. I'm your host for today. As you all know, my name is Adnan. Uh, since you already have some idea about me, I'll just give you a short introduction. Uh, I have an experience from well-reputed companies like Radicop, Impetus, Teradata, and Wipro Arabia. I worked as a Linux administrator and Hi, sorry, I was facing some technical issues. As I was saying that I've started my career as a Linux administrator, a big data administrator, and then I went on as a security consultant. Then I moved my career into the big data development side right now. Along with me, I have my co-host Amir and Gulshad, who hold similar experience with me. Talking about this session, it will be all about making you aware about the most promising and upcoming careers post COVID that you can pursue your careers into. This is very obvious that at this stage, most of the students are under the dilemma of what should they go for in their career. I'm assuming since you have interest in pursuing your future career into field of information technology, this is what you are here with your interest with. Although there are many career paths for you to choose from, but I'll be focusing from the most promising technologies that you can take advantage from and be successful in future. So basically, I'll be discussing on topics like IoT, what is IoT, and basics of IoT, artificial intelligence, blockchain technology, DevOps engineering, cloud computing, and big data. We will be touch basing on these technologies. However, I'll try to give you a general idea about them. Covering these technologies in details will not be possible since it's a very short span of session. We'll make sure that you gain the required clarity on the topics that we talk about, and it will help you to decide what you want to pursue. Talking about this, let's start from the first technology, that is IoT. So let's talk about IoT. What is IoT? Nowadays, you have been looking at very new gadgets and technologies, like you must have seen the self-driving cars nowadays, that you're looking at the cars that drive themselves. The cars, you can see that you have new cars in the market, uh, which can detect the objects and apply brakes by itself. Nowadays, you have smart watches which can track all your details that you go through in your daily life. You have fitness trackers. You have smart home security cameras which are smart, which can detect an activity, a human activity, when you are sleeping and make you aware about it. These are nothing but applications of IoT. Now, IoT is a jargon, but if I say IoT, you can think about it as Internet of Things. Now, you must be thinking that what is this exactly? So, IoT, let's understand the definition of IoT. IoT is Internet of Things, and as the screen suggests, IoT is essentially connecting many devices and creating a virtual network. So, basically, you have different types of sensors. Now, in short, if I want to give you an idea about what a sensor is what you get with your mobile phone, like a gyrometer, like a thermometer, through which you can check your temperature, right? Like a GPS, which can help you give you coordinations about your locations on the map. These things are nothing but your sensors. So, making your sensors connected to each other devices and making a use of it for the betterment of humanity is an application of IoT. So that's what the definition says. IoT is essentially is connecting many devices and creating a virtual network, all of which gather and share data about how they are used and the environments in which they are operated. This includes everything from your mobile phone, smartwatch, refrigerator, washing machines, vehicles, CCTV cameras, router, parking meter, alarm clock, toaster, and etc. These physical devices are connected in a smart way to the internet to share various details which talk with each other and perform certain tasks automatically. That is called as an IoT. Now you must be thinking that you have just seen that where IoT is used. IoT is used in your mobile phone, smartwatch, washing machine, or CCTV cameras. But let us see what are the actual applications of IoT where we can use them and how it can benefit us. Talking about it, now we are going to look at the use cases of IoT. This I called it as a smart city. Now let's see how can we make our cities smart. Let's say for example, one of the use case of IoT is smart parking. I'm sure you must have faced this issue that whenever you go to a mall or any public place, the most difficult thing that you have been facing is with the parking. Using IoT, you can create a monitoring system for parking, using which you can get spaces availability in the city area wherever there is an availability where you can park your car. This is nothing but one of the use case of IoT. Similarly, you can have structural health. Let's say, for example, you have a bridge construction done or a building that has been constructed, but you don't know what is the wear and tear and what is the quality of the infra that has been built. Using IoT, monitoring of vibrations inside the building material and its conditions, can give you a detailed analysis of what is the maintenance period for the infrastructure. It can also help you analyze what is the amount for which you have to allow the building construction to stand. Like this, for example, in urban areas, like, places where you have a lot of pubs, or areas where you have a lot of noise, right? So it becomes very difficult for us to control the noise. Using IoT, you can control the sound. You can create a sound monitoring system wherein areas wherein you have a lot of noise can be detected automatically using IoT sensors, and automatic notifications can be sent to the relevant responsible people so that we maintain a controlled environment for noise pollution. Another use case is a smartphone detection. Let's say, for example, I have my organization, and the clients for which I'm working, they do not allow mobile phones in the area of work premises. It's completely prohibited. But I cannot keep on checking my employees every day. It will create a trust issue between me and my employees. For this, I can use sensors to detect a smartphone or Android devices in the area in which I have my Wi-Fi's and my Bluetooth interfaces, which can detect any smartphone activity, and I can take preventative measures. Similarly, like this, there are many use cases which we can use and apply smartphone IoT use cases in our day-to-day lives. Things like traffic congestion. Have you ever thought that you would have a device in your car which can allow you to drive through a route which is less crowded, right? Let's say a waste management system. Every day, the municipal corporation, they travel through a route to collect all the rubbish materials, all the garbages, right? And it is not necessary that every day a particular bin is full in a particular street. So they unnecessarily waste their time in traveling to that route, to that particular bin to collect the rubbish. So what if we could have sensors which can detect the level of garbage that has been in the containers, and according to that we use this data to optimize the route of the people who collect this. It can help us to build an optimized route for the waste collection and management committees, right? Similarly, we can have intelligent highways, warning messaging systems for people who are driving rash on the highways, and all these things. Now, there is one slight difference here, that is, when I talk about all these use cases, IoT alone cannot help us in building these kinds of robust and smart and innovative revolutionary applications. For this, we require another technology to work with IoT and come up with such beautiful use cases. Talking about this, let's take an example of data drives the connected car. And I'm sure that you must be aware, and most of you all must be amazed with cars. So, talking about that, have you ever thought how come the insurance companies call you before you have to go for a maintenance? In this case, IoT can help the insurance companies to give us a discounted rates on insurance renewal to the drivers who has a low amount of accidents, who drives the car very well, and who has very less maintenance and wear and tear of the auto parts, because insurance companies have a risk, right? They gave you some premium amount that you have to pay to the insurance companies, based on which they are going to allow you, they are going to give you a premium that you have to pay for the next renewal. But using IoT, if the insurance companies can monitor the level of driving, they can give you discounted rates. And this is nothing like a dream. because it is a reality. If you see in US nowadays, people they get discounted rates based on the way they drive. Using that, we can apply it here as well, and it can help people save money on their insurance renewal. Similarly, like that, the government agencies, like the traffic system, can monitor the vehicle speed based on their GPS locations. Nowadays, whenever you are traveling using GPS map, like Google Maps, you can be able to see at what speed you are driving on the highway, right? So this is nothing but one of the use case of IoT, which Google has done using the GPS location and the speed and the distance that you are covering on a route will give you the details about your speed. Government agencies can use these details and they can monitor the speed of the car or a vehicle. And let's say, for example, if a car is speeding at the rate of 100 kilometers per hour in a city area where it is not allowed to do so, they can create area based rules and they can filter out such people and they can then take action, or they can create a summon to such people, right? One more use case I can show you, that's the last one for this car, is like automakers. Now you can see the when manufacturers of the car, they create and they maintain the parts, auto parts for the car, right? So what if these manufacturers could get details about their manufactured parts, at how soon they wear and tear? Based on this, it can help them to manufacture and produce quality parts so that they can compete their competitors in the market. These are only few of the use cases, and the possibility lies abroad. Taking you all to the next slide, that is, how can you use IoT in monitoring in healthcare? Nowadays, in many countries, we have Bluetooth enabled blood labs. I'm sure this must be something very alien to you. You must have not heard about it. But yes, it's true. Let's see this. The Swiss Federal Institute of Technology in Lausanne has created implantable devices that act as individualized blood testing laboratories. The implantable device contains 5 sensors, which is each coated with an enzyme that allows to implant to track the substance in the body, such as glucose and lactate. And this substance tracking is analyzed and then sent via a Bluetooth to a person's device, that is, the patient's device. And if needed, the finding can also be shared with the nearest doctor for further analysis. Can you imagine this? How much relief it can give to the old people or the people who are not able to travel to hospital for regular blood checkups. It can give them these details in real time on their mobile. Let's say when we talk about the diabetic people, the most important thing that they need to know is about their blood sugar. This can be a vital thing for them. So it's like a small implantable device, which means less blood work conducted in labs. They don't need to give blood. They can just use these implantable devices and they can get the blood sugar, which in turns required fewer lab technicians. A doctor's ability to analyze blood work remotely means less time spent on conducting unnecessary face-to-face visits, right? These factors help to alleviate the pressure on the strained healthcare system. Similarly, like this, we have a wearable device which can be stick to your body, and that device can monitor the stats about you, like how many steps you have walked, what is your heart rate, and also it can be used to trigger emergency auto calling system to the nearest hospital in case you have a heart failure or a heart attack, without requiring you to call to the hospital when you are suffering that and when you are in a critical condition. It's such a good thing to have for people who are facing these issues, so that they have a safety whenever they face these issues. Automatically, based on their heartbeat, a monitoring system can automatically trigger a call to the nearest hospital. It is possible using IoT and other technologies hand in hand. Talking with this, I am done explaining about IoT, and I'm sure you must have got some idea about what are the use cases of IoT and how you can how you can find your interest in IoT in case you have a similar interest to do something for the humanity. Talking about this, if you are thinking to pursue into IoT, let me give you some good information. That is, these are the average salaries about of some of the companies within India. You can start from about a package of like around 4.5 to 5 lakhs, and it can go up to like 8 lakhs or 9 lakhs in IoT, and then it can go more than beyond than that, depending on how good you are, depending on how skilled you are. So this is just a small graph that I created just to give an idea about the companies that are recruiting for IoT. So there are many companies in India who are looking to hire IoT developers, and there is a very broad scope for this. Since it's a very initial phase, there are many companies as of now, but there will be more in future. So this concludes my discussion about IoT in this slide. And the next slide talks about artificial intelligence. Have you ever thought about how is it to work in artificial intelligence? I'm sure you must have heard this word somewhere in the movies or somewhere in the articles about artificial intelligence and AI. And you must have not imagined it, but you have already started to use it. Nowadays, you have a mobile phone which can detect when you are smiling, and according to that, it can click your own picture. And this is available in the market in most of the mobile phone. This technology is available in the market. Nowadays, Google or OnePlus or so many mobile brands, they are coming up with AI enabled smart camera. So let us see basically what is an artificial intelligence. Artificial intelligence was first coined by the person J. McCartney in 1955 at Dartmouth conference with plenty of research done on AI. So you must be thinking, wow, this is something very new. I've not heard about it, but sorry to say that it's not new. It's a very old concept, and it's a very old uh, technology that has been growing since 1955. Artificial intelligence is basically a machine's ability to solve problems that are usually done by humans. With our natural intelligence, and computer would demonstrate a form of intelligence when it learns how to improve yourself at solving these issues. Let me give you an example. Let's say, for example, uh, you have a job, or let's say what you do is basically every day you get an invoice, okay, and from the invoice you have to calculate and fill a sheet. So whatever you see in the invoice is a list of products and the amount as an image. You have to fill those details in your Excel or any other application. You have to type it every day and you have to fill those details. Now, how artificial intelligence helps you is it comes with that what you do with your ability as your natural intelligence to read that image, understand the characters from the image, and then type it on your application. This can be automated. Artificial intelligence can be used here to read all those details from the image and do this work for you. So this is like a repetitive work which can be automated. The person, J. McCartney, proposed a quote describing the machine learning or artificial intelligence, saying that every aspect of learning or any other feature of intelligence that can, in principle, be so precisely described that a machine can be made to stimulate it in an attempt will be made to find out on how to make these machines use language from abstractions and concepts, solve kind of problems now reserved for human and improve themselves. In simple words, what he meant to say is we are going to research on how humans think, and we are going to try to replicate this intelligence in machines. And now you can see that there are machines and there are robots that have been built which can think like humans and talk to humans with their own emotions. So let us see, and also, yes, a definition about artificial intelligence, which you can see on the screen, is artificial intelligence is intelligence exhibited by machines rather than humans or other animals. The field of artificial intelligence research defines itself as the study of intelligent agents, any device that perceives its environment and takes action that maximizes its chance of success at some goal. In short, whatever intelligence human have, we will record that, and we are going to record and feed this intelligence to machines so that we make our life easier and we can focus on new things in our life. Let's see artificial intelligence in action, how it can help us. Now, as we were discussing about IoT, I mentioned to you that only IoT cannot solve the day-to-day issues. There are other technologies that work hand in hand with IoT. So, artificial intelligence helps IoT to do these kinds of use cases. For example, GPS is used to get a rough location of the car. The car can easily be recognized on the road marking signs and traffic lights. Nowadays, the government has started an initiative that if you break the signal, you are monitored from the cameras and a summon will be issued directly to your phone and you have to make the payment. Summon is nothing but it is the challan that we say. Also, the car even detects roads or cyclists and safely navigate around them to prevent accidents from happening. Or the smartphone is used for picking up the user's location with the destination set, like your Uber. When we talk about Uber, that's what Uber is, right? When you book a car, you do not select your location, but your location is automatically detected where you are standing even after you book the location. And if you're walking down the streets, your location will be live shown to the driver, which can in turn arrive at your current location rather than the location that you have selected previously. So this is all possible with all these booming technologies working hand in hand to, to create solutions for human. Let's take up another use case. These are some news articles around the globe of how they are using artificial intelligence in their real life. Let's say, for example, let's look at the first article. Apple supplier Foxconn replaces 60,000 workers with robots and China factory. Or let's say, watch robot builders construct houses in 2 days. Or a Moli robotics bot make nearly 2,000 different types of meals. Can you imagine a robot making a meal for you with the same taste every time, whatever you want to, whatever you want it to make for you? Or let's say Flirty launches world's first pizza by drone. These are just in commercial trials, and they're planning to deliver for Domino's pizzas as well. So these are some of the articles which are, you can see, artificial intelligence, how they are being used in your day-to-day lives. Now, when I talk about artificial intelligence, it is not just one scope, but there are different scopes inside artificial intelligence. Initially, what humans or the artificial intelligence team, I would say, used to do is they used to understand the actions that human do. They used to write logic, and based on that logic, they used to improvise the program that they used to write, which can help a human or a robot to act similar way. This is what was traditional artificial intelligence. Now, with as we went to the evolution and we developed, and then inside artificial intelligence, we have we have machine learning, which is like a subset of artificial intelligence. What it does is it provides the system the ability to automatically learn and improve from experience without being explicitly programmed. So let's say I would give you an example of artificial intelligence. Uh, let's say you are a pilot, okay? As a pilot of a flight, you have an option of an autopilot, right? So I cannot let the flight decide based on the sensors and think about himself, because it is very risky. I cannot do that. For that, I am going to prefer artificial intelligence. I'm going to write a program which is going to monitor everything and then take decisions. I would never want that machine to think on itself based on the data. So that is one of the use case of artificial intelligence, wherein a program is explicitly being made to for an artificial intelligence autopilot, and that program is being improved with over time to make it more perfect for the flight, for the pilots. And if I say about machine learning, wherein you don't need to predict, or you don't need to write program explicitly, the machines are going to learn by themselves, are applications like video surveillance, social media services, or let's say email spam and malware filtering, or like predictions when you're commuting to your workspace. You must have seen nowadays that when it is time for you to leave to your work, you automatically get a pop-up from Google saying that today's travel in your route, there is like a lot of traffic, so you can prefer to take another route, right? So this is one of the example or use case of machine learning, wherein you don't program, but you feed a certain amount of uh, conditions and data to your program, and it starts thinking on its own, and you have to just survey or monitor that decisions that the machine is making, and just help the machine to make decisions by telling him that is the decision what he has taken is right or wrong, and the machine is going to improve its own self. Like a small child, when he's growing up, and you guide him to right and wrong, or the good and bad practices, the similar way we are going to train the machines to think on themselves. And there is another subset inside machine learning, which is called as deep learning, or we can say neural learning. It's again a subset inside machine learning, which we use neural networks to analyze different factors with a structure. Now here it is with a structure that is similar to human or neural system. When I talk about structure in neural learning or deep learning, I am talking about how you can differentiate between a chair and a bed. How can you differentiate between a two-wheeler and a three-wheeler? How can you differentiate between a three-wheeler and a car? Right? So whenever you see a car and you see a two-wheeler, automatically you know it, that it's a motorcycle and it's a car. How you know it? It's because of your natural intelligence. It's this intelligence which you have in your own self, right? But then what we do, the way we think and the way we differentiate between a two-wheeler and a four-wheeler is, first of all, we know that a two-wheeler has a two wheels, right? And a four-wheeler has four wheels. It has a different dimension, this has a different dimension. And the same way, this is how a deep learning or neural learning is functioning. It takes these conditions, that a chair should have four legs, it should have a back to rest, a bed should have four legs, but it is not necessary to have a back to rest. This is the differentiation between the two. And this is how the machine, it takes decision by itself, by some conditions that are given to him. And with over time, it is going to analyze the images, the structures, and it is going to tell itself, and it is going to perfect its own self at one point of time, wherein it is going to be smart enough to detect all these structures by itself. Some of the examples, if I want to give you uh, about deep learning, is like virtual assistants. Do you know, nowadays when you speak or when you give a call to customer services, some of the companies, they have virtual assistants. You won't even recognize that it is a robot talking to you. You will feel as if you're speaking to a human. He will talk to you naturally, and he will divert your call to the relevant department. But it's not a human, it's a virtual assistant which is doing this work for you in the back end. Or let's say, some for example, you must have seen YouTube, or you must have seen Vimeo, or you must have seen Netflix. How do you think that you have watched a certain series, and when you finish watching that particular series, you get a recommendation based on what you have watched? This is nothing but a recommendation engine, which is another use case of machine learning artificial intelligence. This goes with the YouTube and all other platforms, which, it gives you a recommendation of a movie similar to your interest. So these are some of the use cases and how you can differentiate between artificial intelligence, machine learning, and deep learning. Artificial intelligence is where you explicitly program the thing, and you improve that, improve the intelligence of your program. Machine learning is, you program it once, and then the machine learning keeps on improving its own self. And deep learning is about differentiating between structures and images and videos and all those contents. Talking about this, I conclude on speaking about artificial intelligence. Let us look at some of the salaries, because we always need to know. We are always interested to watch how much a person can earn if we pursue this career. So let us take you to that slide wherein you can just have an idea about how it will be like entering into machine learning. That slide wherein you can just have an idea about how it will. So an average salary of a machine learning starts from about 30 to 40,000, and it can go towards a lakh or more than that. So see, this is just a figure. It's just an average figure. It is going to keep on changing. It's not constant, and it's not necessary that what you see here is going to be that same thing. You can get more, because as we grow, as the recession, or as the conditioning of the market changes, the salaries are going to differ. But one important thing that I want you to focus is that you have a very bright future in all these technologies that we are discussing. If you can see on this image, you can see here so many openings that you are looking at. All of them are looking for the interns, right? May it be a machine learning, artificial intelligence, may it be IoT, may it be any other technologies, cloud or big data or anything like that. There are so many companies who are looking to hire interns, college graduates with good percentages, who have good percentage, and they are going to hire them, they are going to give the salary, and when they are getting paid like a stipend, they are going to train them as well. So you have a very bright future. If you want to make a career, you can start pursuing these technologies and make a good career out of it. Talking about this, we move on to the next technology, that is blockchain. So blockchain, you must be you must have heard about it, or you must have not. It's not much of a common concept nowadays, but for some it is common and for some it is not. Blockchains are incredibly popular, and it's starting to get popular slowly. Like the name indicates, a blockchain is a chain of blocks. It contains information. Okay, so every block inside this graph, let's say the graph that you're looking at, you have a mobile phone, you have a laptop in the image. It's every node, or every block I say, is connected to each other. Like every computer is connected to each other, every mobile is connected to each other, and every mobile or a computer, they have a block. It is called itself a block, and it has data. So basically, we are talking about data. So it stores data. Now we will see an overview about blockchains and understand the basics of blockchain, how it can benefit us, and as well as what are the jobs available in the market in India. Okay, talking this, let's move on to the next slide about the overview of blockchain. Before I go to the overview, on its most basic level, if I want to explain you what is a blockchain, it's a blockchain is like, at the basic level, is a new class of information technology, that combines cryptography with distributed computing. Now, these two terms, what you heard, that is cryptography and distributed computing, let me elaborate on these two components, these two things. Cryptography is something that you use day to day in your life. If you, I'm sure most of you all are using WhatsApp for communication. Okay, so whenever you are communicating through WhatsApp, you will see a note saying that, don't worry, your messages are encrypted, and it cannot be unencrypted by any other party except WhatsApp. Your messages are safe and private. No any other hacker or any other company or third party company can read your messages. Neither the government can read your message unless they want to do so. Okay, so this is a basic example of what I called as encryption or cryptography. Cryptography is, it combines, coding and creating an algorithm which can encrypt your plain human language into something which cannot be understandable by other people, but can be understandable whoever has the code. And the second term, which I said, distributed computing, is basically nothing but, let's say, for example, you have a Excel file in your computer, okay, and you are doing some work on the Excel file. Now, tomorrow, the data has increased so much that you cannot use your laptop to do that work. So you move on to a server in the cloud. Now, when I'm talking about the server in the cloud, it is not just one machine, but virtually you are looking at working on one computer, but on the hardware level, it is not one machine. There are millions of machines which are connected to each other, and they are giving you a virtual machine, that is your computer, which you are getting to see online. Or let's say, in other words, you have one laptop, you are working on a data, may it be Excel file or anything. But now tomorrow the data is too much. So what you do is you connect another laptop and you share the data. And this happens again, the data is increasing. You connect the third laptop and you distribute the data. So this is nothing but distributed computing. And we are going to discuss about this in details in our further slides. But at a most basic level, blockchain is nothing but a combination of encryption, that is cryptography, with distributed computing. All the mobiles and your laptop, they connect to each other to create a platform for sharing the resources, sharing your memory, sharing your storage, and creating a huge space. This technique was originally described in 1991 by a group of researchers, and was originally intended to work for timestamp digital document. So it is not possible to backdate them or to tamper them. If I explain you in a very layman language, let's say for example you own a land. Okay, you have a land with you, and you have your own brother. Okay, nowadays, or let's say not a brother but a friend or anyone else, but there is a dispute on that land title, right? There is a dispute on the land title. The person on the other end says that it is his land, and then you say it is your land. And then what you do is, basically you create a title dispute, and then you went go to the government regulations, and then you, yeah, and you know, they take your cases. They go and they do the research in their office. They try to track the owners in the documents. How they are going to track? They have a ledger system. When I call about ledger system, is nothing but there is no changes made. Let's say for example I take a land today, there will be an entry made today, then tomorrow I sell this land to anyone else, then the previous entry is not going to be erased. It is going to be there, only a new entry will be made. Okay, this is like a ledger system wherein the things are not erased. And it the once the data is there in the books, it is going to be there forever. Like the government, how they, verify the land titles is based on the ledger system. They never delete any details of the land you are selling to anyone. It is just going to keep on appending new information. So this is the technology. When it was initially coined, it was used to timestamp the document. So it is not possible to backdate them or any tamper with them or play with them. You know? The data is distributed over a number of devices, and it makes it distributed and secure, and hence trustworthy. It is trustworthy. Now talking about this slide, data, as I said, combines cryptography with distributed computing. It has existed for a number of decades, but we just came to know about recently about this. It was introduced in 1991. It was mainly adapted by, in 2009. This is where the blockchain actually came very well known to the people, the publicly. Why? Because in 2009, a guy named Nakamoto, sorry for that, Satoshi Nakamoto, in 2009, he used this technology, that is the blockchain technology, to power bitcoins. There was a hype, in few years before that, the bitcoin is rising, and the amount of the bitcoin is going up, and there are so many people who are investing in bitcoin. So this was basically a blockchain adapted by this guy in 2009 to power bitcoins. Now, when I talk about bitcoins, it's not legal in India, but just to give an idea, it is nothing but a cryptocurrency. Okay, it's nothing but a cryptocurrency. What we have right now everywhere in the world is a paper currency that we deal with. You have 100 rupees, you have 1000 rupees note, 2000 rupees note, you have a 500 rupees note. Whatever you have in your hand is a cryptocurrency. Previously you used to have a barter system. I'm sure you must have heard and read about this in your history books, right? You used to have a barter system wherein, if you have a land, and if you're giving your food that you're growing in your land to other person, in return the person is going to give you something of value. He may give you gold coins, or he may do the same work for you, or something like that. So it was a barter system. But nowadays it is, we have revolutionized, and nowadays we have a paper currency. But the world is growing, my friend. The world is growing, and we have cryptocurrencies as well. Cryptocurrency is nothing but a currency which is not a paper. It is a digital currency which holds value. So that's what a short idea about cryptocurrency is. It is digital, it is not in paper. It is simply a distributed secure database. When I talk about blockchain, as I already discussed, it is a distributed secure database. And initially, blockchain, the generation one blockchain, was largely functioned as a database. So initially, when it came and people starting to using it, the first generation of blockchain was largely focused on as a database and nothing else, for no other work. But since the evolution, we we improvised, and now we have the second generation of blockchain, uh, which already provides you the capability to execute even a computer or any computer code on the blockchain. Now when I say blockchain is nothing but your mobile or your laptops which are connected to each other. Giving you a short overview about blockchain, let us see what is basically a blockchain is. As I already told you, it is a distributed ledger completely open to anyone else. A distributed ledger means a distributed database. In simple words, it is a database which is not sitting on a one computer or one mobile. It is distributed on different mobiles, and hence it is it's broadcasting a bigger database with using the network and your mobile phones or your laptops as your base for big database. Once the data is recorded inside this database, it is permanent, it cannot be changed. So let's say, for example, each in your block, let's say in your mobile phone or anything like that, you purchase a bitcoin. So whatever you have purchased is a permanent record. As I told you, right? Taking an example of a land, you purchase a land, you sell it to someone else, it cannot be changed. It is going to be there. That entry is going to be there. Similarly, like that, whatever transactions you do, it is never deleted. Every block, that is your laptop or your mobile phone or any other server, is encrypted with a unique identifier called as an hash. I'm sure you all are from engineering background and you know what is hashing, right? So you have 256 bit hashing, and then you have 16 bits and different kind of AES encryptions. So this is nothing but like a hash. For example, I have a plain text of lines, and it is encrypted using hashing technique. And after hashing, it's not a normal language. It's like a binary language, and I cannot read it. So that's what is done. A block that I spoke about in a blockchain. So every block, it has some data, okay, and it has its own hash, as we discussed previously. And with this, with the data and the hash, it also has the hash code of your previous block. That is the previous block it is connected to. So blockchain is nothing but like a chain, any kind of a chain which is very linear, right? It has one dimension, it is in one straight line. So one block is connected to the previous block is connected to the previous block. It's like a chain. That is what a blockchain is. Our data is stored inside, depends on the type of blockchain. So whatever data you are going to store inside this block or a mobile or a computer, it depends on what type of data you are going to use it for. You have different use cases, so you can store different types of information in this blocks. The Bitcoin blockchain, for example, let's take an example of a Bitcoin block. Bitcoin blockchain stores the details about a transaction in here, such as the sender and receiver. I took a block Bitcoin, I sold it to someone else, or I took a cryptocurrency, I sold it to someone else. This information is going to be recorded. Now, tomorrow, a person receives that block, he needs to verify from whom he has received, he can track everything. A block has a hash value, okay? But now you must be thinking, okay, I have some bitcoins, now I can track who initially purchased this. So it's not possible, okay, because there are some rules and regulations of what level of data that you have access to. So you will not have details in depth, but you will have at least a detail about from whom you purchased. So that one level of detail you might have, but this is governed by a different authority who takes care about all these details. You can compare a hash like a fingerprint. So how your fingerprint is very unique and it cannot be replicated with anyone else's fingerprint. This is same like a hash. That is what I call it as. This makes the blockchain very secure. That means people who want to apply this technology in their use case, this will help them, and it will create a level of trust between them. Talking about this, this is what was about blockchain. Average salary of a blockchain. So this is like to give you just a short idea about what it's like to be a blockchain developer. There are different job roles as well in blockchain, and yes, you can see that in India there are opportunities to work as a blockchain developer, uh, as an intern as well as an experienced developer. You will get a good opportunity if you want to make a career into a blockchain developer. With this, I conclude the discussion on blockchain. The next topic that I'm going to move towards is DevOps. The word itself gives you two different words. So this DevOps, the word that you're looking at, is derived from two different fields. One is dev, which stands for a developer, and OPS, that is operations. So we have developer and operations. So a DevOps guy is someone who has expertise in both. So before we move on to the definition of what is a DevOps and how it works, uh, let's say, for example, you have a software. Okay, you are a developer. Okay, and you have come up with some new updates. So maybe like you have developed an Android game. You have developed a Ludo. I'm sure you must all of you all have been playing Ludo. Okay, so you are working, you have created a game called Ludo. People are using your game. Okay, and somewhere they have they are facing a bug or some security related issues or anything like that, and they have highlighted this to you. As a developer, you have written the improvements and the fixes which is going to fix these issues. Now what you need to do is, your next job is, you want to test this first, and after you test this, you want to put this to production, so that this update will be available and it is going to solve the issues of your end users. Okay, so what challenges you face as a developer, let's look at that, and how DevOps is going to help you. So let's say you have come up with new products or features or security updates or bug fixes. But unfortunately, when we see as a traditional approach, okay, whenever you develop a code, you need to wait for weeks before your code is put into production, before whatever changes you have made is applied on your actual game. You need to wait for weeks. This is the traditional approach. You need to do the testing, you need to do the unit testing and all the things, and then you have to go to the production. This will increase the pressure on you, right, in becoming competitive in the market. You want to be your game to be error free, and you don't want to lose customers, and you want to make these changes available in a very short span of time. But because of this traditional approach, this is going to increase the pressure in time. Okay, there will be an increase in time to market, right, for your code to reach to your main game. Now after waiting, when your code is ready now and it is supposed to go to the production testing, you face another issue, that is dependency issue. So let's say, for example, the code that you wrote was for a particular Android game mobile phones, but now there are new type of versions, there is new type of Android version, and now by the time you tested your code and the code is ready and then you applied it on your game, there is a new version of Android and all the users have updated their Android mobile version, and now again you went into back to the past. That is, your code is not compatible with the new Android version. So now This is the challenge which is very common, and the developers face this. So this is called as a dependency error. Mostly happens because you wrote a code for a development environment or for an environment that is not identical to the current mobile device that people are using. On the other hand, the operations guy who was handling the machine or the server of your game for you is now burdened with so many people using your game. So he what he has to do is he has to expand the number of servers so that he can cater with a very good performance to all the people playing across the globe. You're getting so many people playing your game. So he's occupied with a lot of responsibilities, and it is he has to maintain many things, and the tool that he's using to maintain and administer these servers is not as effective as it was before, because previously he had only one system, but now he has to take care of 100 systems, 100 servers. So it's very time consuming for him. So this is challenge to the operations on how the new code is deployed in the production. As always, when we deploy code to production, it requires little tweaking. Tweaking means, like, you have to change settings to make your code run successfully on the destination devices. So once the code is deployed, everything is done. The operations responsibility basically is, once the code is deployed successfully, then after that, whatever issues they face, it is the responsibility of operations guy to diagnose that issue. Once the developer has done his work, operation guy has to take it from there. Okay, to help both of them. Now see, when talking about this, operations guy cannot, he's so busy that he you have to book the time slot when your code is going to be tested and it is going to be live. So operations guy has to give you a schedule for which you have to wait, right? So to help both of these people, the developer and the operations guy, to ease their problems, we have something called as DevOps. So DevOps it is basically it is a way of thinking. Okay, it is a way of thinking. A DevOps is something that, you have a lot of tools in the market. You have to use those tools and think like a DevOps, how you can provide solutions to the problem of operations and a developer. Talking about this, let's go to the definition of DevOps. As we discussed a lot about DevOps, DevOps is a combination of development and operations, and is a software development method that stress communication and collaboration and integration between software developers and IT professionals. Thereby, DevOps helps enable rapid evolution of products or services. As I told you, right? You have your customers complaining you about there is some bug in the Ludo game or PUBG, and let's say, for example, you are trying to give a headshot to other user in the game, and that headshot is not happening. There is some bug, and you have raised it, and the developer has written a code to solve that issue so that the user have a good experience. Okay, so this is what DevOps is. It helps these developers and the companies to stay up to date and to be up to the mark with their competitors. It reduces the risk, improves the quality across portfolio, and reduces the cost. Now, since we know the definition of DevOps, let us see actually what DevOps does. Now, this was just an overall idea, right? So let us see what actually the DevOps guy does. So, DevOps guy basically they focus. Their main focus is on automating everything. So basically, the DevOps responsibility is to automate every area of the domain that they are into. As you can see on the image, they want to automate network monitoring, IT asset, change management, service desk, storage domain, compute domain, uh, the servers that they are going to launch, or the application or the database that they are going to provision on the infrastructure they are going to provision. They want to automate everything. In fact, they want to automate the testing as well. Whatever code the developer is going to write, they don't want to, just sit and wait for the developer to give them the code. They want to automate everything so that the developer does not need to wait for the operations guy to run this code and test it. The developer should be automatically able to test his code as soon as he writes it, rather than waiting for months and months to do the testing and come up with the errors. So, in short, their focus is to automate everything like code testing so that the developers do not need to be dependent on the operations guy. Automate workflows, automate infrastructure. Let's say from testing of new code onto how the entire infrastructure that they have built step by step, how can they automatically create a huge automation where entire infrastructure is provisioned in just clicks. They would write softwares in small chunks and integrate and monitor and test and deploy them. So usually in hours versus the traditional way of writing the software over weeks or months. And then they do months of testing and then they come up with errors. Basically, DevOps helps to eliminate all these problems. Okay, they would build also, let's say for example, you have Ludo King the in production, okay, but you can't write code and test them in production. You have to have a backup similar kind of environment, that is a developer environment. Okay, so that is where you write the code, you test it, and then you move this code to the actual production machines. So now what you the most common issue that most of the developers face is whatever code they write in development, they could not run efficiently in the production because both these environments are different. They are not equal to each other because of the configuration. Both the configurations are different. The environment is sometimes different. They are not identical. So this is another the next challenge for DevOps to integrate both the